David's my name, and in today's diagnostic module we're going to be having a look at circuits containing relays. Relays are an extremely important part of today's modern car. We've only got to look under the bonnet and open the fuse box of one of these cars and we'll see there are relay circuits everywhere. Diagnosing these relays should be a piece of cake, but I've seen a lot of strange things happen over the years. I've seen people pull relays apart and have a look inside and see if they can find what's wrong. You might well be able to tell what's wrong with it, but you can't buy the parts to fix them anyway, so what's the point? I've also seen people try and measure the resistance of a relay. That's great if you know what the resistance should be, but in today's modern relays we have a spike protection resistor, so even if the coil is open circuit, you're still going to measure a resistance, so it doesn't really help us. I've seen people bridge circuits in relays with a piece of wire, usually pins 30 and 87. We never use a piece of wire to bridge a circuit. In automotive, we always use a fuse jumper. That's the only safe way to do that. I've seen people almost dismantle a car trying to get at a component so they can test to see if it has 12 volts there. And worst of all, we see people swapping relays. Now, swapping a relay in a modern car, if you take a relay out, you don't know what effect that's going to have on the operation of the vehicle. It might even affect the circuit that you're trying to diagnose. And if you pull a monitored relay out, you'll set a DTC. So swapping relays is not the answer. But there is an even easier way of testing relays. And when you become proficient at it, it will only take you a minute or so to do. And that's what we're going to have a look at today. So let's go over to the diagram. We're going to be using a horn circuit in this example. We can divide a relay into two separate parts. The part on the left is the control circuit, and the part on the right is the load or the switch circuit. Looking at the terminals, we can see terminal 86 and 30 are connected to a fuse. They will have constant battery power on them. Pin 87 goes to our load, which in this case is a horn, and then to earth. Pin 85 goes to the switch. This switch is mounted on the steering wheel and only operates when it is pushed. So pins 85 and 87 will have a ground on them. When testing a relay circuit, we first remove the relay. We're then going to measure the voltage at pin 86. We put our multimeter probe on pin 86 and then on a good vehicle ground, and we should see battery voltage. We do the same thing to pin 30. We put our multimeter probe on pin 30 and then a good vehicle ground, and we again should see battery voltage. If battery voltage is missing from both of these spots, the fuse is the most likely culprit. Moving down to pin 87, this time we're looking for a ground through the horn to the body of the vehicle. So we put our multimeter probe on pin 87 and then to a good battery supply. We again should see battery voltage. Now we move on to our last pin, which is 85. We connect our multimeter to pin 85 and a good battery voltage, and then operate the horn switch. We again should see battery voltage. If all of these voltages are there, there's only one problem that we can have, and that's the relay itself. Let's have a look at this vehicle. The customer's complained that the horn doesn't work. The first thing we should do is validate the customer's concern. And sure enough, the horn doesn't work. So let's diagnose this relay circuit. The first part of our diagnosis involves removing the relay. So we pull the horn relay out. Now we're ready to do our voltage tests. The first test I'm going to do is on pin 30. Pin 30 should have a battery on it. So we put our test probe into pin 30. And onto ground, and there we have our battery voltage. The next pin to test is pin 86. Pin 86 should also have a battery on it. And there we have our battery voltage again. The next pin we're going to test is going to be pin 87. Pin 87 will have a ground on it. So this time our multimeter has to go to battery positive. So we'll hook our lead onto battery positive. Put our probe into pin 87. And hook it up. And as you can see, we have our battery voltage again. The last pin we have is pin 85. But this time we've got to operate the horn button to get the ground. So we'll operate the horn button. And as you can see, no voltage appeared. So there's our problem. We don't have a ground on pin 85 going to the ground through the horn switch. So that's the part of the circuit we start to diagnose now. If all of the voltage had been correct, there's only one culprit that's left, and that's our relay. And that's how we test relay circuits. And that's circuits containing relays. We've just shown you a very simple and effective method of testing relays and relay circuits. There's no guesswork involved in this. We know exactly what the problem is straight away. It could be in the relay or it could be in the circuit itself. And always remember that this method can be applied to any relay, be it 4-pin, 5-pin or whatever. All we need to do is look up a schematic and find out what pins have batteries and what pins have grounds and simply go and check them. If all the batteries and grounds are in place, that means that the relay is at fault. I hope you found this informative, and always remember that training is your key to success. Bye for now.